On the evening of 13 April 2029, a rock roughly 375 meters wide will slide past this planet at a height of about 31,600 kilometers. That puts it under the ring of geosynchronous satellites we use for television and weather. It carries a name borrowed from Egyptian myth, Apophis, and for a few hours it'll be a moving point of light you can find with your own eyes, no telescope, from Europe, Africa, and Western Asia. It will not hit us. NASA ruled that out in 2021, and the ruling covers at least the next 100 years. So take the honest answer to the question in the title up front. Nothing in the known catalogue can destroy the Earth. Not one object. Wrecking a planet and ending a civilization are separate jobs, though, and the second one sits well within reach of things we haven't found yet. Start with what the word destroy actually costs, because the number is ridiculous. To break the Earth into pieces that never fall back together, you have to beat its gravitational binding energy, the sum of everything holding it, in a ball. Physicists put that at roughly 200 million trillion joules. Estimates of the Chicxulub impact, the one that finished the dinosaurs, start around 100 million megatons of TNT and climb from there. Take the friendliest figure on that list, and you still need something like 500 million Chicxulubs, all arriving in the same instant. Nothing in this solar system can pay that bill. The largest near-Earth asteroid on the books, a body called Ganymede, measures around 35 kilometers across, and it sits in the AMA group, which by definition never crosses Earth's orbit. The closest it can get is roughly 51 million kilometers. The one object that ever came near the job was Theia, the Mars-sized body that, in the leading account of where the moon came from, hit the young Earth. The Earth survived even that. It kept the iron and spat out the moon. Apophis earned its reputation the hard way. Roy Tucker, David Tholen and Fabrizio Bernardi picked it up at Kitt Peak on 19 June 2004, and by that December, the calculated impact probability for 2029 had climbed to 2.7%, one chance in 37. It reached level 4 on the Torino scale, still the highest rating ever assigned to anything. Then an archivist's kind of victory. Someone went back through old survey images, found the asteroid sitting there unrecognized in frames nobody had thought to check, and pushing the observation arc back a few months to March 2004, collapsed the uncertainty. The 2029 impact evaporated the same day. A radar campaign in March 2021, run through the Goldstone dish and the Green Bank telescope, cleared the following century too. What survives is the flyby, and the flyby is worth having. Earth's gravity will bend the asteroid hard enough to shift it from one orbital family into another, from an Arton to an Apollo, while we watch. The European Space Agency signed the build contract in February 2026 for a spacecraft called Ramses, worth €81.2 million, to arrive in February 2029 and ride out the encounter alongside it. NASA's OSIRIS-APEX, having dropped its Bennu sample in the Utah desert, has been renamed OSIRIS-APEX and is already heading for the same rock. So much for the ceiling. The damage lives lower down the ladder. On 15 February 2013, an asteroid roughly 18 meters across came in over Chelyabinsk in the southern Urals at about 19 kilometers per second. Nobody saw it coming. It arrived out of the daytime sky, on the sunward side, where no ground telescope can look. It never really reached the ground. The main airburst came near 30 kilometers up, releasing energy in the range of several hundred kilotons. The shock wave needed a couple of minutes to make the trip down, which meant thousands of people were standing at their windows, filming the smoke trail when the glass came in. Around 1,500 were hurt, almost all of them cut. More than 7,000 buildings damaged. Nobody killed. 18 meters of stone did that, and it was the most energetic thing to hit us since 1908. Multiply the diameter by 3, and you get 1908. Early on the morning of 30 June, something detonated over the Podkamenaya Tunguska River in Siberia, somewhere between 5 and 10 kilometers up. Researchers put the object somewhere between 40 and 80 meters, and the yield in the megaton range, though published estimates spread from about 3 megatons to 50, depending on whose model you trust. There's no crater. What there is, still legible in aerial photographs decades later, is 2,150 square kilometers of forest laid flat, millions of trees pointing outward from one empty center like iron filings around a magnet. The first scientific expedition didn't reach the site until 1927 because the region was that remote. Move the same object a few hours around the planet and it lands on a European capital instead of a swamp. Tunguska's only mistake, from our point of view, was the address. The top rung is the one everyone already pictures, and it's genuinely worse than the pictures. Around 66 million years ago, an object 10 to 15 kilometers wide struck the shallow sea off what's now the Yucatan. Researchers dating the crater rock have pinned the event at 66.043 million years, plus or minus about 40,000, which is a level of precision that ought to be against the law. The scar runs more than 180 kilometers across. Roughly 3/4 of all known species were gone by the time the sky cleared, the non-avian dinosaurs among them. And yet the planet itself came through. Darkened, chilled, poisoned for a while, and structurally untouched. It kept its oceans and its air and its orbit. Life carried on in the burrows and the shallows, and one of those burrowing survivors is the reason anyone's here to worry about the next one. That's the worst event in the geological record, and it reads as a species filter rather than a planet killer. Which raises the useful question: if we did spot one coming, could we do anything about it? In September 2022, NASA answered with a half-done spacecraft and somebody else's moon. DART flew into Dimorphos, a body around 160 meters wide orbiting the larger asteroid Didymos, on the 26th at roughly 6 kilometers per second. Dimorphos had been circling its parent every 11 hours and 55 minutes. Afterwards, the JPL team measured 11 hours, 22 minutes and 3 seconds. 33 minutes and 15 seconds taken off an orbit by one machine on the first attempt. The bar the mission had set for calling the test a success was a change of just over a minute. Most of the effect didn't even come from the collision. It came from the plume of rubble blasted off the far side, which behaved like a rocket exhaust bolted to the asteroid. ESA's HERA spacecraft launched in October 2024, and it is due at the pair by the end of this year. It will survey the crater and weigh what's left, so the next attempt can be calculated instead of hoped for. Here's the part worth losing sleep over, and it isn't the big ones. Kilometre-class asteroids are largely accounted for because the surveys have been hunting them for 30 years and the population is small. The gap is in the middle. Congress instructed NASA in 2005 to find 90% of near-Earth objects 140 meters and larger, the size that flattens a metropolitan area rather than a forest. 2 decades on, the tally sits somewhere near 40%, and even that number wobbles depending on which estimate of the total population you trust. At the present rate of discovery, the job would take decades more to finish. NEO Surveyor, the infrared telescope built specifically to close that gap, launches no earlier than September 2027, and it needs 5 years of survey after it gets there. Until then, we are partly blind in exactly the size class that ruined Tunguska. The last real scare came straight out of that gap. Asteroid 2024 YR4 was picked up at the end of December 2024, and within weeks, the impact probability for 22 December 2032 had climbed to 3.1%. That put it at level 3 on the Torino scale, the second highest rating anything has ever been given, behind only Apophis. Telescopes across the world swung onto a rock that the James Webb Space Telescope would eventually measure at 53 to 67 meters. Tunguska class, in other words. Earth came off the table. Then the Moon went on it at 4.3%. It took Webb observations on 18 and 26 February this year for NASA's Center for Near-Earth Object Studies to shut the file. YR4 will miss the Moon by 21,200 kilometers. 14 months of work, a space telescope, and a great many careful people to become certain about one small stone. So could an asteroid destroy the Earth? No. Nothing we've catalogued comes remotely close to the energy that would take, and the objects that could are not in our neighborhood. The question was always aimed slightly wrong, though. The Earth doesn't need destroying. It only needs one bad morning. Chelyabinsk cost a few thousand windows because it came in shallow and burst 30 kilometers up, and that was the largest thing to reach us in a century. We didn't see it. We couldn't have. On 13 April 2029, when Apophis crosses the sky over Africa and Europe, looking like an ordinary star in an enormous hurry, remember that it took 17 years of watching to be sure it wasn't coming for us. That is the whole of planetary defense in one line. The only asteroid you're safe from is the one you've already found.